Alright, hello everybody. So, today I'm going to be talking about section 1.1 in Algebra for College Students. And we're going to be starting off by talking about a rational number. So, a rational number is a number that can be written as a fraction, otherwise known as the a over b format. So, the a over b format, where b is greater than 0, makes a fraction. If b is equal to 0, the fraction is undefined. An irrational number is a number that cannot be written as a fraction. Pretty simple. So some examples of a rational number are 2/3, 0.6 repeating. Note that the bar on top of the 6 means that it continues on as 6 for an infinity amount of times. 2.3, 1.25, and so on. So from these examples, we can observe that terminating and repeating decimals can also make a number rational. As you can see, 2/3 is equivalent to 0.6 repeating, which is a repeating decimal, as you can see from the bar on top. So, and then we can also see that 2.3 is a rational number, or is a rational number, yeah, and it terminates at the 3. It doesn't go on like 0.6, which makes this number rational. So some examples of an irrational number are pi 0.273954, and then 0.65432198757.3. Okay, so we can observe from these 3 examples that a non-terminating decimal and a non-repeating decimal make a number irrational. Pi has an infinite number of digits. It does not terminate, nor does it repeat. Same with these numbers. These 3 dots signify that the number keeps on going even further. So, and as you can see from here, the number does not repeat in both examples. Alright, next we're going to talk about whole numbers. So whole numbers are 0, 1, 2, 3, 4, 5, 6, and all the way up to infinity. Natural numbers are 1, 2, 3, 4, 5, 6, all the way up to infinity. So natural numbers are basically whole numbers, but without the 0. And then integers. Integers are from negative infinity to infinity. In the example, I've shown these 3 dots, meaning that they go all the way back to negative infinity, and these 3 dots showing that they go forward to infinity. And rational numbers, irrational numbers, whole numbers, natural numbers, and integers, they all make up real numbers. So next we're going to talk about PEMDAS. Hopefully you know what this is, but if not, PEMDAS means parentheses, exponents, multiplication, division, addition, and subtraction. So PEMDAS is an acronym that we use for order of operations. And in the next 4 examples that I have, we will use PEMDAS to solve the examples. Alright, let's get into it. So if you know how to do it, and you just want to check your answers, you can just pause the video, and then do it by yourself. If not, I will do these examples with you. And yeah, so let's start off with example number 1. We have 7 times 4 divided by 2 times 3 times 2 divided by 4. Alright? So we're going to start off with multiplication, which is in PEMDAS. So 7 times 4, which is 28, divided by 2, times 3 times 2 divided by 4. Alright? Now, here is where it kind of gets confusing. So at PEMDAS, you see that multiplication comes before division, right? But really, what we're going to do is we're going to do the division first. We're not going to do the 2 times 3 times 2. No. The reason why is because multiplication, division, addition, and subtraction, they go from left to right. So to explain that is, if you look from the equation left to right, if you see multiplication first, you're going to do that. But if you see division next and then multiplication after that, you're going to do the division first and then the multiplication. So we're going to do 28 divided by 2, which is 14 times 3 times 2 divided by 4, right? And now 14 times 3, which is equal to 42 times 2 divided by 4. We get 42 times 2 is equal to 84 divided by 4, which is equal to 21. Right? Now we're going to go on to the next example. If you feel like you got the hang of it, go ahead, pause the video, and try this one yourself. If not, follow along. So we have 20 plus 6 divided by 10 times 2. Remember, multiplication and division, addition, subtraction, they all go left to right. So as we look from left to right, we see 20 plus 60 divided by 10 times 2. So since we see the division first before the multiplication, we're going to do the division first. So 20, we're going to bring the 20 down, plus 60 divided by 10, which is 6, times 2. Now that equals to 20 plus 12, which makes it equal to 32, right? Yeah, 32. Alright? Pretty simple. Now the next one's a little bit more complicated, but if you just follow the rules of doing it left to right, and this one requires the P in parentheses, so if you know how to do it, go ahead and pause the video, do it yourself, and then come back and check if you got it right. If not, just follow along. So we're going to do 3 times 2, which is 6. Okay, make sure you put the parentheses there. Let me fix that 6. Okay, and then we're going to put down the plus. Then we're going to do 4 times 5, which is 20. And then we're going to put the next parentheses there. We're going to do 6 times 8, which is 48 minus 35, alright? Oops, forgot to end the parentheses there. Alright, now we're going to simplify. So 26, and then this is 13, right? Yeah. Okay, and then this is going to be equal to 338. Now, we have parentheses, and we haven't, in order to break the parentheses open, you're going to have to multiply it, which we did here in this last step. And if we ignore the parentheses for this, like if we want to just solve this, this area, okay, then we would do regular PEMDAS procedures. We would do multiplication, which is 3 times 2, and then 4 times 5, and then we would do addition, because multiplication comes before addition. Same thing over here, except this one's subtraction, and then you would just simplify it, and then you would have 26 times 13. So when you have a multiplication like this, or when you have 2 parentheses like this, it almost all the times means multiplication. Okay, moving on to the next equation, or the next example. We have 6 times 8 divided by 4 minus 2. All of that over 5 times 4 minus 9 times 2. Okay, so this bottom part is really easy because we did a similar example right here. 6 times 8 minus 5 times 7, right? So we're going to do the 5 times 4 multiplication first. Just put a denominator sign there. So 20 minus 9 times 2, 18. Okay. Next, since it's multiplication, division, left to right, we're going to do, since we see the multiplication first, we're going to do the multiplication first. We're going to do 48 divided by 4 minus 2, okay? So 48 divided by 4 is 12 minus 2 over 2, okay? And then you're going to just simplify the numerator, which brings you to 10 over 2, which is equal to 5. That is the answer. Okay, so do we have one more example? No. Okay, so I am available for private tutoring sessions if you really need it. If not, and you just want to contact me or something, go ahead and use the email. Otherwise, I hope you stay safe during these times of COVID-19. And yeah, have a great rest of the day.